Hello, welcome. In this short video, let us look at plots of the shifted version and time reverse version of the unit step signal. So specifically, we are going to look at the following signals. That is, we will plot the following signals. Given the signals x1 of t is equal to u of t. So that is a unit step signal. So we have to plot several variations or transformations of this signal. So for example, x2 of t will be equal to u of t minus a, where a is the shift. If a is positive, it will be a delay, and if a is negative, it is an advance. So we will plot them in Matlab. So for theoretical reference, u of t minus a should look like the following. So we are going to look at this u of t minus a in Matlab. So for plotting this signal u of t minus a, all we have to do is first define the limits and the amount of shift. So say the shift is equal to 2 and the limits are something like shift minus 5 and limit 2 is equal to shift plus 10. So for plotting purposes, and then we call the function my unit step shift with the parameters limit 1 and limit 2, that is the starting point and the ending point, and the amount of shift in the variable shift, and then the sampling rate n. So in the function, we define the time vector t with the limit 1, that is starting point, to the ending point and the given sampling interval 1 by n, and then we define the vector x with all zeros, and then we use the definition of the shifted unit step, that is it is only for only values of time t greater than the shift value, it will be equal to 1. So when we run this code, you can clearly see the results. So for example, when we shift this signal unit step signal by a value of 2, we can clearly see that the signal value 1 starts at t equal to 2, and up to that point it is 0, and it is 1 after that point 2. So we can change this value to a negative also, and we can clearly see that the starting point of the signal is at minus 2. That is, the signal is advanced by 2 steps or value 2. So it starts at t equal to minus 2, and it is 1 for all the values greater than minus 2, and signal is equal to 0 until the value minus 2. So this is the shifted version of the unit step signal. Now let us look at the time reverse version. x3 of t is equal to u of minus. In that case, the theoretical signal, the graph should look like following. So the signal is equal to 1 for values of t up to 0, that is from minus infinity to 0, the signal value is 1, and after that it is basically 0. We can also look at this plot or realize this plot in Matlab as follows. So in this case, again we define the limits, the starting point and the ending point, and the sampling rate. We call the function my unit step, which basically generates the signal u of t, and then we reverse the time, that is we replace the time with negative values, that is it's negative, that is t is equal to minus t1 in this case, and then we plot t and x, that is we plot t comma x, so that we get the time reverse signal. So clearly we can see that the signal value, the signal u of t is time reversed, and that is the value of the signal is equal to 1 up to 0, and that is from minus infinity to 0 it is equal to 1, and after 0 it is basically 0, that is for all positive values of t it is 0. So this is time reverse unit step signal, that is u of minus t. Thus u of minus t can be plotted. Now let us look at the combination of both shifting and time reversal. So we are going to look at the signal x4 of t, which is equal to u of a minus t. That is, it is both time reversed and shifted. Now first let us look at what how the graph is supposed to look like. So that is that should be the structure of u of a minus t, and if a is greater than 0, then this u of a minus t should look like this, and if a is less than 0, then the starting point, that is the ending point of u of a minus t, that is it will look like the following. This is for the case where a is less than 0. Here a is positive, here a is negative. So that will be the structure of u of a minus t. Let us verify this in Matlab. So again we do the same things, that is we define the sampling rate, we define the shift value, and then we define the limits, and in this case we modify the definition itself, that is we look at the, let us look at the function. So we define the time limits, so starting point and the ending point, and with the required time interval or the sampling interval, and then we look at the definition, that is x is x, the signal x or the signal unit step is basically going to be equal to 1 for only values of the time which are less than the shift value. That is, as long as t is less than a, the signal itself is going to be 1, otherwise it is going to be 0. So we will use that definition. X of t less than or equal to shift is equal to 1. So that means the value of the signal u is equal to 1 as long as t is less than a, which basically means that the unit step signal is equal to 1 for only positive values of the argument. So here that is what we are using. T is less than or equal to shift means the argument of the signal is positive, then only it is equal to 1. So thus we can plot the both time reversed and shifted version of the unit step signal. So for example, we are using a is equal to 5. You can clearly see that the signal value is equal to 1 up to t equal to 5 and 0 after that. You can also look for negative values and we can verify the definition. Say minus 4. So the signal value equal to 1 stops at minus 4. We can clearly see that the signal value is equal to 1 from minus infinity to minus 4 and 0 after minus 4. So to summarize, in this video we have looked at 3 different transformations of the unit step signal. The first one is the shifted version of the unit step signal, that is x2 of t is equal to u of t minus a. So if a is positive, that means it will shift towards right of t equal to 0, and if a is negative, it will shift towards the left of t equal to 0. So we looked at this one. So we verified this one in Matlab as follows. So we have my unit step shift function, where we define the function such that the value of the signal is only equal to 1 for t greater than or equal to the shift value. This t greater than or equal to the shift value, the signal is equal to 1. So that's a shifted version of the unit step signal. Now in the second case, we have the time reversed unit step signal. So u of minus t. So that means the value of the signal is 0 is equal to 1 only from minus infinity to for example 0 for this u of minus t. So this also is verified. So we have this my unit step function, we call that one, and then we reverse the time value so that we can easily plot the time reverse signal. So the time reverse signal looks like this, that is, it is 1 from minus infinity to 0. Finally, we have both shifted we have both time reverse and shifted version of the unit step signal, that is u of a minus t. So if a is positive, it will stop after 0, and if a the value 1 will stop after 0, and if a is negative, the value 1 basically stops at value a, which is less than 0 or before 0. So we can verify this one in Matlab. Again, we define a new function in which we clearly use the definition of this u of a minus t. That means we define the signal to be 1 only for t less than or equal to the shift value. So when we plot this signal, it looks like. So for example, if the shift value is minus 4, then it is basically stopping at minus 4. That is, the value 1 is the signal value is 1 only from only up to minus 4, and it is 0 or later on. That is, it is 0 after minus 4. And we can also verify this one for positive values. So clearly for the shift value equal to 5, the signal is 1 up to that point and 0 later on. Thus we have looked at the 3 different transformations of the unit step signal: the shifted unit step signal, the time reversed version, and also a combination of the two. Thanks for watching.